So apparently today is my day for technical difficulties, y'all. So this is going to be question 6, which we replaced from the original review, and then 11 through the end of the review. Okay. So NASA engineers designing a mirror will be attaching it to a satellite. The mirror will be shaped in the shape of a polygon with 4 sides. Are the 2x plus 5, the 6x plus minus 7, and the x minus 4. The perimeter of the mirror must be, so it tells us the perimeter of the mirror is 12x plus 12. What is the length of the fourth side? What does it need to be? Okay, so what we're going to do is we're going to add these 3 sides together here that we have. Okay, so we're going to add 2x plus 5 plus our 6x minus 7 plus our x minus 4. Now remember, there's a 1 in front of that x, right? Okay, so we're adding 2 plus 6, that's 8, plus another one, that's 9x. And then 5 minus 7 is negative 2, and negative 2 minus 4 is negative 6, okay? So now what we're going to do is we're going to take the whole perimeter, which is the 12x plus 12, and we're going to subtract from it what we got for the other 3, the sum of the other 3. So that's going to be 9x minus 6, right? Now remember, when we subtract, we're going to change the signs of everything and then change it to plus sign, okay? So we're going to make that a minus, we're going to make this a plus, and then we're going to add them. So 12x minus 9x is 3x, and then remember, minus and minus is why we got that plus, right? So then we've got plus 12 and 6, that's going to be 18. So that is what our fourth side will be. And if we added these two together, they should equal this, and that's a great way to check it. All right, so the next question that was new was number 11. So we're going to talk about this one, okay? So we're going to break this up into 2 sections because it says find the area of the L-shaped carpet. So we're going to do this little section down here first. Okay, this is the first section we're going to do. Okay, so notice it's got these tick marks here and here, and that means that we can bring this top 2x plus 1 down here as well. And then we're going to bring it down to here because that's going to give us that total width, right? Okay, so 2x plus 2x is 4x, and 1 plus 1 is 2. So now we have our base and our height. So when we find the area of a rectangle, we do that by multiplying the base times the height. Okay, so that's exactly what we're going to do here. We're going to multiply our 4x plus 2 times our x, okay? And that's going to give us 4x times x is going to be 4x squared. And then 2 times x is going to be that 2x. Now we're going to find the area of this other rectangle up here, and ultimately what we're going to do is we're going to add them together. So this is going to be our second part right here, number 2, right? Okay. So again, we're going to multiply our base, which is our 2x plus 1 times our 5x. We're going to distribute this to both like we just did a second ago. So 2x times 5x is 10x squared, right? 10x squared, and then 5x times 1 is obviously 5. Anything times 1 is itself, okay? So what we're going to do now is we're going to add these together because that's going to give us our total area. So the x squareds are common terms, right? They're like terms, so we're going to do 4 plus 10, and that's going to give us 14x squared. And then 2 plus 5 is 7, and that's going to be 7x, okay? All right, so this next part, number 12, says give the image coordinates of h, which is 4, negative 6, after the translation. So all we're going to do here is we're going to take the values that are here. We're going to put this in for our x because it's in our x position. We're going to take this right here and put it in for our y, okay? So what we're going to do is we're going to do 4 plus 5, comma, negative 6 minus 7, right? So that's going to be 9, comma, negative 13. And that's going to be our h prime. That's our new point, okay? Now, we're going to do this next one a little bit different. It says, what is the translation vector for the given point? So we got our x's here. So we're going to do negative 9 plus a x equals our negative 7, okay? Then we're going to do our y's. So we're going to do our negative 1 plus a y equals 3. So all we have to do here is get everything except for our variable on the other side. So we always do the opposite operation, so we're going to add 9 to both sides here, right? 9 plus 7 is 2, so this is x is equal to 2. We're going to add 1 to both sides, and that's going to be y is equal to 4. So when we write this as a vector, remember we use these funky brackets. So that's going to be 2 comma 4. All right, so on this next section, let me scroll up here. It says match the graph with the correct transformation. Okay, so what we're going to do first, we're going to work through some of these, okay? So remember, what we did in class was we connected the original, which is without the tick mark, where that's the prime. So we're going to go A to A prime, B to B prime, C to C prime. And what do you notice about these three lines? Hopefully you notice that they're all parallel, right? But they're not all congruent. So what we want to do is bisect these lines. And I see that that can be bisected by a line like that. And that's the line y equals x because it has a slope of 1, right? So that is our line of reflection. So that means this answer is C. Okay, on this next one, we're going to do the same thing again, and we're going to notice something really interesting. Okay, so if we go from B to B prime, and we go from C to C prime, and we go from D to D prime, well, notice they, first of all, they are not parallel. They cross one another, right? So this tells us that this is going to be a rotation, okay? So when we do this, we're going to look at one point, and so we're going to go from C right here around to C prime. Notice we went one quadrant. Now remember, one quadrant is 90 degrees, right? We could also go the opposite direction all the way around this way, and that would be 270 degrees clockwise. So now that's E, right? Okay, then our next one, again, we're going to draw those lines connecting those vertices, A to A prime, B to B prime, C to C prime. Again, notice they're all parallel, right? But they're not all the same length. So we are going to bisect them again. There's our line of bisection right there. So isn't that the y-axis? So yes, that is our line of reflection. Then, so it's a reflection over the y-axis, so that's going to be B. Okay, let's keep working down through here now. Okay, this next one, again, we're going to do the same thing we've been doing. I'm going to connect x to x prime and y to y prime, and then z to z prime. Okay, notice these are straight lines through the origin. That's one hint that this is a 180 degree rotation. But the other thing is they cross, right? So now when they cross, that tells us it's got to be a rotation. So we're going to again look at, I'm going to go from y to y prime, and I'm going to go this time, notice I'm going 2 quadrants. So that's going to be a 180 degree rotation, right? Okay, now remember, this doesn't matter whether it's clockwise or counterclockwise, okay? And that's because it's the same either way, okay? Now this next one, again, we're going to draw these lines from T to T prime, R to R prime, S to S prime. Notice they're all three the same length, and they're all parallel, okay? So once again, this is going to tell us that this is a translation, and we can tell it's a translation from T to T prime of 1, 2, 3, 4 right, and then 1, 2 down. Y'all see that? So this is a translation. Thus it's H. That was the only translation in here. Okay, then our next one, again, we're going to connect A to A prime, B to B prime, I think it's under there somewhere, and C to C prime. Again, notice they're all parallel, but they are not congruent, so there is our line of reflection, and we bisect those lines, right? Those parallel lines, okay? So this is the x-axis, isn't it? So that's a reflection over the x-axis. And that is A. All right, got a couple more down here. So this next one, again, we're going to connect A to A prime, B to B prime, and C to C prime. There's our cross right there. Okay, so we know it's going to be a rotation. All right, so let's look at it. So we're going to go again. I'm just going to pick B here, and I'm going to go from B up here to B prime. And I went, you notice 3 quadrants, right? So that's 270 degrees. Now, if I were to go the opposite direction, right, like that, that would have been what? 90 degrees clockwise rotation, right? So this one, let's go back up here and see what this one was. G, right? Okay, so this one is G. Got one more, right? Okay, so here again, we're going to connect A to A prime. We're going to connect B to B prime. We're going to connect C to C prime. Can you tell those are all parallel? Me too. Now what are we going to do with them? We're going to bisect them. Just like that. And isn't that the line y equals x? So that's our line of reflection, right? So this is a reflection over y equals x, which was C. Okay?